A full adder is a digital circuit that performs the addition of 3 binary bits. It adds 2 input bits, labeled A and B, and a carry-in bit from the previous stage. A full adder has 3 inputs. The first input is A, which represents the first input bit. The second input is B, which represents the second input bit. The third input is Cin, which stands for carry input. A full adder has 2 outputs. The first output is sum, which is the resulting bit after the addition. The second output is Cout, which stands for carry output. This slide presents the truth table for a full adder. The table outlines all possible combinations of inputs and their corresponding outputs. The columns A, B, and Cin represent the 3 input bits, and the columns sum and Cout represent the sum and carryout bits, respectively. For instance, if A, B, and Cin are all 0, then sum is 0 and Cout is 0. If A is 0, B is 0, and Cin is 1, then sum is 1 and Cout is 0. If A is 1, B is 1, and Cin is 1, then sum is 1 and Cout is 1. The sum output is determined by the equation sum equals A exclusive or B exclusive or Cin. The carry output is determined by the equation Cout equals AB plus Cin multiplied by A exclusive or B. This slide shows the gate implementation of a full adder using logic gates. 2 XOR gates, 2 AND gates, and 1 OR gate are used. The inputs A and B are fed into the first XOR gate. The output of the first XOR gate and the input Cin are fed into the second XOR gate to produce the sum output. The inputs A and B are also fed into 1 AND gate. The output of the first XOR gate and the input Cin are fed to the second AND gate. The outputs of both AND gates are then fed into an OR gate to produce the Cout output. Full adders are used in multi-bit adders, such as building blocks for ripple carry adders and parallel adders. They are used in 4-bit, 8-bit, and 16-bit arithmetic circuits. Full adders are also used in digital systems as a core component in arithmetic logic units, or ALUs, and microprocessors. They are found in central processing units or CPUs, calculators, and embedded systems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.